Hello, everyone. Today, I'm going to teach a new concept. The name of concept is transfer of learning. This is the second session that we talk about neural network, and more specifically, deep neural network. Let's dig more into it and understand what does this concept talking about. Okay, so basically, in transfer of learning, we enjoy pre-trained neural networks, usually developed by large corporations, for example, Inception, V3, ResNet, and utilize their power to predict some new outcomes. So basically, because of some similarity, we can incorporate a pre-trained deep neural network. So let's just have a quick review on neural network. So basically, in neural network, you have an input layer, one or more than one hidden layers, and at the end, we have an output layer. So the role of hidden layer is just identifying some features of our observations. When we want to train such a models, there is some optimization algorithm under the hood that they find coefficient of each arcs or arrows, as you can see in this figure. Finally, we have output layer that has activation function, such as logistic or sigmoid, softmax, ReLU. So the output of the last layer usually is a probability or a score that, based on that score, can understand the class of your input observation. Okay, so let's look at this problem for an example. Let's say you use real animal images to train a deep neural network, and you have a very good algorithm that could predict image of animals with, let's say, more than 90% accuracy. Okay, so this is a well-trained algorithm. So it makes sense that you can use this model to predict images of toy animals. Look at this figure. So you have two different cats, probably different genders. So both of them have some specific facial features, like they are fur animals, their nose, their hands. So there is some similarities between these two, but they're not exactly the same. So in transfer of learning, so our inputs are usually different, but the rest of the neural network is same. Just the last part, which we have activation function, might be a little different. Okay, so going back to the previous problem, with the different activation function at your output level, you can predict if it's a like cat or it's not a cat. Well, let's see how it works. Let's just dig more into that. As you might remember, in deep neural network, each layer works kind of as a filter. For example, if you look at this figure, the first layer maybe can find edges, the second layer maybe corners, and the last maybe could be object parts. Maybe like going back to this example, maybe the last layer for identifying like ears, eyes, paws, so on and so forth. Okay, so knowing that, we are basically trying to predict something same. It makes sense that we could use almost similar deep neural network. We don't have to train everything from scratch. Maybe with just a small tweak at the last layer, we can use same model that is trained with the real animal images to predict the toy animal images. Okay, so we are in the big data era, and as we said, training a large data set might be very time consuming, especially for image data sets. Usually, we don't have access to such big computers that can train large deep neural network of millions of pictures. If you can utilize those algorithms, you can have a much more faster algorithm and probably can predict better. Even this example, let's say we have 1 million real animal images and we have just 1,000 toy animal images. Even if you don't use the pre-trained model on the real animal images, your current data set of toy animal images is very limited. Maybe even if you train everything from scratch, maybe you end up having a lower predictive performance. Okay, so let's look at it in a bit different example. So let's say you spend years of driving with a gas-powered car, any like traditional gas-powered cars. So you learn how to brake, accelerate, how to like make signals. So now if you want to buy a new car, let's say new electric car, you don't have to learn everything from scratch. You don't have to learn how to brake, how to accelerate, how to make signals. You still need a little bit of learning, but not that much. Okay, so as we said, when we are working with large data sets, training machine algorithm might take a lot of time. On the other hand, there are some famous already trained model and even more observations. So not only we can have a faster training time, we also probably could have a better accuracy if we just use a pre-trained model that exposed to much more larger data set. Okay, so having said that, in transfer of learning, it should be some similarity between observations. And we are using a very powerful pre-trained model. We might just change a little bit of it and use it for predicting a new data set. So having said that, if you look at this figure, so probably we need to have some pre-processing at the beginning, and we don't need to just use optimization algorithm to find the weights between different layers. We just might need to just train the output units that has an activation function and be able to have a very high accuracy. So there is a lot of application for transfer of learning, image classification, natural language processing, medical images, robotics, audio processing, and recommended systems. And you just can keep going. Okay, so let's say what we want to do for today. So in this experiment. We are working with the C410 dataset. It is gathered by or hosted by a professor from University of Toronto. It has 60,000 observation or 60,000 different 30 by 32 color images in 10 different classes. And the classes are fairly distributed, in which we have 6,000 image per class. And our classes are airplane, automobile, bird, cat, deer, dog, frog, horse, sheep, and truck. So this is our current data set. We want to use Inception V3, which is a pre-trained deep neural network developed by Google Research in 2015. It has over 23 million parameters. Just look how big it is. And it has so many hidden layers of convolutions. Basically, it's a convolutional deep neural network. This model is trained over 1 million different images with 1,000 different classes. So this is a very powerful deep neural network. But what we are going to do for the experiment? So we need to do a little bit of pre-processing, which makes our data set ready for this experiment. The only change that we have at the end, we use a logistic regression to predict the class of our observation. So basically, the only changes on Inception 3 is the last layer, which we use logistic regression. By the way, you can use any type of models. We are using community version of Databricks. Also, I don't expect you have a very powerful PC. So logistic regression usually is one of the fastest algorithms that we can utilize. Even for the experiment, we don't use the whole of C410. We just use 1,000 observations for train set and 100 for test set. So let's see, even by using this small data set, can Inception V3 brings up a good prediction rate. Okay, so I already provided the notebook for you guys. This in which on the left side with the purple one is Inception 3. We're going to use for the blue one or turquoise one on the right, which is our new model, which is basically children of Inception V3. Okay, so first you need to install some packages. So by the way, if you want to run these codes on your own PC, probably you need to uninstall some of the packages. And you might also need to increase the dedicated memory to your codes or to your notebook. When you use Jupyter Notebook for running this code on your PC, there's a default dedicated memory. If you run out of that memory, maybe you get some errors, but just keep in mind you might need to do your own research and just increase or decrease the dedicated memory. Anyway, so let's assume everyone use Databricks. So first you need to install TensorFlow. If you install TensorFlow, then you need to install scikit-learn. And then you need to install OpenC. After doing that, you need to restart Python interpreter. So with this code that I put here, so dbutils library restart Python, we restart and load last libraries that we just installed. By the way, for this online recorded session, I might talk a little fast because you can just pause anytime with your notes and keep going. If it was in the class, probably I pause by myself, but here I'm just going to make video shorter than like a complete session. But I already knew that you can pause the video and just think, focus when you need to change some codes by yourself to learn more. So don't hesitate to put your own comments. Anyway, so the first section, I'm importing the required packages, so such as data sets from TensorFlow. Within that data set, I'm going to call C410, logistic regression, some evaluator, vector assembler, pipeline CV2, and goal, dense vector, NP, and random function. And I'm going to call Spark session builder and create an app for our project. The name is Transfer Learning. Okay, so having said that, from dataset, I'm loading C410, and I assign my test train images, the label, test images, and their labels. So if you want to get more information, just Google C410 dataset, and you will be headed to this page. You can download these files, I mean the image files, on your PC and access to that. But since we are using the TensorFlow datasets, you don't have to download from there. But by looking at this page, you can get a lot more information about that dataset. Anyway, so by the way, still we are using the community edition of Databricks. The memory is limited. Even I've noticed the execution time is different in different times of a day. When I ran it early morning, I could get result much faster than afternoon. So anyway, from 6,000 from 1 to 6,001, and 1 to 1,000, I just pick 1,100 observation randomly, and these are subjective. You can just change the range or like change the number of observation. But anyway, here I'm just using 1,000 observation for train and 100 for test set. So you need to do a little bit of pre-processing in which you need to flatten the image array and convert into the vectors and create tuples with corresponding label. Here, label means the type of picture or the name of the picture. If you want to get some extra information, what does flatten the image array means? I recommend to at least get a online course from LinkedIn Learning, so you can get some good knowledge of what do I mean. I assume it's not a common thing for everyone, and also we haven't had a very deep course on deep learning. Then I avoid them. But these are basically are some pre-processing that we do. So we make our images from a 2D to 1D to one array and just feed our deep neural network. Still, you need to do some extra things. So you need to resize your image to 224 by 224. And yeah, you need to exert some features. Just let me skim through that. I know that people who already had deep neural network, a kind of deep neural network course, where they can understand much more. But again, these are some pre-processing. You need to extract some features and basically return those extracted features as a dense vector. And after that, you can just feed your Inception V3 deep neural network. Anyway, as you see here, we need to do some complex things in the way that change our pictures into NumPy array and then make it a Spark friendly. As you might remember, similar to the previous project, when you want to make a Spark friendly data set for training, your data need to be in two columns. One is features that has your independent variables, and the second is a dependent variable. Here we call it label. So features have the elements of your images, and label is your dependent variable, which say what does each picture means. This part might take quite a bit of time. Actually, the pre-processing here is much more time-consuming than training the actual model. Okay, so this part might take between 10 to 30 minutes. It depends on when you use Databricks, the community version of the Databricks. So after feeding our data into Inception V3, by the way, look at the model that I used. I said, okay, call Inception V3, but don't include the top. Top is false. So again, here means the last layer or the topest layer, that's activation function. I'm going to replace that with what? With logistic regression. And this is multinomial logistic regression. I'm using this model, train this model, and then just do evaluation and just report the performance of my predictive algorithm. So I fit on the train data, I transform my test and train. Basically, it just means I apply that algorithm to both of my train and test sets. With multi-class classification evaluator, I can get the accuracy of my model, both in train and test. And if you look at the results, so the accuracy of my train is 99%, near 100%. And the test accuracy is 81%. So first, both are pretty high, but the catch is there's a huge gap. So it seems I had overfitting on my train set. Assuming that here we didn't use whole data set for training, I just randomly picked 100 observation, which is usually for image processing is low. So we should have a couple of thousands of observation at least. And also test is pretty small here. Given the limitation that we impose to this problem, it should be fairly okay, although this is not a perfect model. So you can also blame that this is not a good model and everyone accepts it. But anyway, the purpose of this notebook was exposing you to the new concept of transfer of learning. So you have learned that you need to do some pre-processing, making your data set ready for a deep neural network. Chop off the last layer and just impose a machine learning algorithm and train the input of that machine learning algorithm and try to predict the class of our observation. So let me go to the figure again. So here, let me just draw a line. It's a part of just, okay, so, okay. So the last layer, this one, is what we are going to train. And it just have two inputs. Sorry, one input and one output. So input is arrows that goes to our machine learning algorithm, and the output, this is a class of object. For example, this is cat, dog, whatever. Anyway, that was for today. If you have questions, please reach me out. Again, sorry that this session is online. As you might remember, I had an issue with my computer because of some random reason, and I tried to make it available for Databricks so all of you can have the experiment. Okay, see you guys in the next session.